we're starting on time today. My name is Markus. Welcome. Sorry for that. I work for Red Hat as a developer advocate, and beside traveling, I actually do write technical articles about all kinds of things that catches my interest. And coming from a very enterprisey background, because I have been a consultant in the field for more than 14 years by now, I do like Java EE. This is my first ever confession. So if you share my passion at that point, and you have been working like in enterprise settings before, like I did, you might be wondering what you could do to actually adopt latest buzzwords. There's been plenty out there recently, right? So Docker, images, microservices, you name that. And the idea is how to make that fit into a sustainable enterprise Java architecture. And this is what I'm trying to explore together with you a little bit. So one of my favorite quotes up there today, so we used to do stuff because we have learned to do it over the years. When I first started with Java EE, it was back on WebLogic Server 5.1, and it was like called J2EE back in the days. And nobody really knew how to build applications with that. Remember those times where those big Bibles about how to master EJBs came out? Like introduction to the first ever EJB component model? That's been insane. I haven't seen like books like that size in a while. So we kind of worked our way through, and we learned our lessons about object-oriented programming, about containers like Java containers, J2EE containers. And whatever we did, we more or less ended up with an application that looked like this one. It was basically an ER file containing all our modules, like WAR files and jar files and whatever. And we deployed that whole thing to a running instance somewhere. Maybe we had something like an enterprise access management system or various databases that we needed to connect to. But at the end of the day, the whole infrastructure has been in place. And the only thing that we took was our binary, and we threw it on there. And I can't really recall the number of times where this cycle didn't work back in the days, for obvious reasons. So the technical implications of such, let's say, standard J2EE, Java EE architecture, they are comparably immense. People tend to call it a monolithic application, which is like, it starts to be a word which I dislike heavily because it implies it's no longer maintainable, it's kind of a spaghetti code. Doesn't have to be, don't get me wrong. Like, it's just a big thing that we deploy on an infrastructure and rely on the infrastructure capabilities to scale out and make that actually perform to a certain extent. But we end up having that single package. And if we really want to reuse something, we ended up building jars. So who never has been building anything like a common jar? We all had, right? So if we had like a business feature that we want to reuse across many applications, that was a really rare feature because it easily turned into a framework with APIs. So literally nobody did that. And those applications had another nice impact. I'd like to call it the 24th of December impact, because we put them to production like once or twice a year. And I can't recall the number of times before, like a long weekend or a holiday or especially Christmas, something new had to be out just in time for a particular date. And we actually had to push it out, right? No matter what. We had a single database scheme, and we had really large applications back in the days. So 500,000 lines of code was kind of a small thing. I recall having seen applications more in the 2 million lines of code, plus not mentioning the 8 million lines of code in PL SQL on the host. But that's been like a really large thing. Who has to deal with like WebSphere application servers? Okay, at least 1 or 2. What's the average wait time to get that thing up? Right? Huh?
30 minutes.
Well, that's a really long thing. Definitely, I've seen like 15 minutes to be comparably normal for really large applications. And the whole infrastructure just, it feels heavyweight, right? I mean, not talking about whatever we have like in terms of specific IDEs. What's that called today? No longer rational application developer. It's architect in the meantime, right? Right. So anyway, one particular part of my former job was that I actually was like introduced by my boss as the dinosaur of the company. That isn't really something that flattered me a lot, but what he meant to say is, if you have an issue, call Markus. And all the projects around did that, so I had to firefight kind of 30, 35 projects a year. And whenever I stepped into one of those projects, I actually tend to look at the test cases first, because I really want to understand what that application does, right? So most likely they had thousands, literally thousands of test cases, but nothing newer than like a year ago. So basically, the initial project creation phase was the big thing. This is the time when everybody invested something into test cases. When a project goes into maintenance mode, nobody really fixes test cases or adds new ones for new features. So it's been insane. But that's not only, I mean, we have had technical implications. What else did we have? We had team implications. Those projects I've been witnessing have been really large teams in general, like 20 plus members. The largest team I've been involved with had over 200 developers on it, and that's quite a size. Most likely because we had a bunch of testers also that had to go through like a multi-month test cycle to test that application. Funny enough, like Excel sheets, test cases, going through it, checking it, and just clicking, because nothing was automated back in the days. Feature databases, bug databases, literally we didn't know when the application actually fulfills all the requirements, because user acceptance tests, that's not been something that we've defined back in the days. And another nice thing that we rarely realize today actually is that we had a very technical design of the whole application. So we've been talking about layers instead of domains a lot of the time. So still, like, the presentation guys had to fight the backend guys and the database guys, and that was kind of the overall theme in all those big applications. And at the end of the day, the more complex the thing grows, the more people need to be involved, and the more time you had to spend on getting a reasonable overview about the complete project. But we managed, right? I mean, we suffered. I spent nights in front of the computer. I spent nights with teams eating pizza, drinking beer, trying to fix stuff. But the requirements still kept changing. Even if a project is actually in production, we still do need to address like legal requirements or whatever new features the business actually wants us to implement, right? And one side effect of those technical layers and those large teams with very few people who have real oversight was that you really had to implement new features mostly across the board. And this was a big thing to do, especially new cross-cutting concerns literally were totally impossible to implement. And I think this is where the word monolithic got such a bad reputation from. Again, it doesn't have to be like that, but from the very early beginnings where we learned everything, it looked exactly like that. But why? What's the reason for that? Have we been stupid? Have it been us? It's a mixture of many, many things. I think we've been learning on the job a lot. We kind of accepted like technical debt. What's the WebSphere version you're running on? 8, fair enough. That's reasonable version number. But still, the project I was working on, they haven't updated their application server over the complete project lifetime.
because there was literally no need to, unless operations decides to flip the switch and actually put a new thing into production. Obviously, we ended up with a bunch of technical debt. We had mostly outdated infrastructure, so we were barely able to use new features that made our life easier. So another good example is like today's Java E7. Who is using Java E7 in production? Literally nobody. Okay, one reason for that is we don't have that many final servers out there. Just a heads up, EAP7, like the supported version of Webflow application server, is just around the corner. But again, the whole technical debt pattern was going through the whole project up to operations. And of course, we've been lazy, right? We've been working like 8 to 10 hours a day, and we didn't want to educate ourselves. And actually, this is something that you guys aren't, because you are sitting in a conference and you do something against your personal technical debt, which is something I really admire, because you learn something new. Keep doing that. Okay, a bunch of things. And I think nobody was really to blame for that. We learned on the job. We created something new. But what did we learn, actually? So where did we go from there? And where did we end up, actually? It was the era of integration. It was the very first start of some new acronyms, of some very interesting new 3-letter acronyms. From now on, we treated all our outdated applications as legacy. We actually maybe implemented something like web services in them and had like a centralized infrastructure to wire them back together. And this centralized thing was obviously called an ESB. And web service, all the things, was a pattern for many, many years. So some random companies actually bought like these large ESB installations for a shitload of money, sorry for that. And they really tried to wire everything together. And a lot of logic actually ended up in those ESBs. And it wasn't a bad idea. I mean, we wanted standards, right? So we had like a web service standard. We could just use that centralized infrastructure and wire everything together. Still, we need to integrate stuff. That's never going to change. And maybe some of those ESB actually could hook into like host systems in the basement, so we didn't have to cover them anymore. And seriously, it was kind of enterprisey. All the vendors just went out and sold the hell out of enterprise service buses. It was the thing that enterprises just had to have. What else? Oh, centralization was a really big important thing here, right? So instead of having like a totally decentralized integration, point-to-point infrastructure, those centralized service buses definitely promised a lot more governance and a lot more control. So that was another big point. Downside, I said that, licenses. So there's been a lot involved in terms of licensing. What else? Well, how did those applications end up? Again, we had a bunch of technical things. So the code bases pretty much didn't change, except that we pulled in a lot more code by just having to expose web services. My favorite is still the overloaded IDEs. So whoever had to work with a real serious ESB product, according to the vendors out there, had to use something like JDeveloper or IBM's Pendant, whatever. And as far as I know, JDeveloper is like 4.5 gigabytes download, which is just the installer, and it's just totally bloated. What I found really hard is to understand those centralized modelings and infrastructure, because there tend to be a lot of code in there, even on the ESB end. So it was not just routing and transformation in the ESB. Plus, it's literally impossible to test, because you really need a test system for everything that you want to have some data from, including the ESB. So the complete project went into complex dependency mode. And I've been spending a lot of time like troubleshooting all those various systems. And believe me, you will hardly find a test system of a host in the basement, because there's only one, the production service. At the end of the day, even the smallest changes somewhere downstream, which haven't been tracked like centrally, generated a big impact for the whole project. And that was just insanely difficult. Not talking a lot about scaling. I mean, we learned a lot on the way, but scaling ESBs, scaling centralized infrastructure components always has been like a really big challenge. And I would love to put in a quote here, but I at least heard 3 to 4 architects saying, we don't have to program anymore. We can just rewire our applications and everything works. And actually that was a funny idea. Most of the ESBs supported some kind of inline routing logic. So you could simply fire up your IDE and put in some JavaScript magic or whatever random functional language you had at hand and add some features centralized without touching the original applications. That's fair, but it's unmaintainable at the end of the day. Plus, nobody ever thought about data segmentation. So every single application had their own big data model. We didn't even touch them, right? So we ended up having a different customer object in one application than in the other. And we really didn't know about what to talk. So every application was run by a different department. So it basically shit hit the fan at that point because they couldn't find an agreement which user was the right one to use. Another scaling is difficult. Okay. We learned a lesson. So this is all screwed up. Nobody is actually doing it. And the few that are doing it have probably learned some lessons and started to scale out the ESB infrastructures by layering them. But what does a modern infrastructure look like? If all that, what we've done, is kind of doomed to fail, so what could we do better today? Who knows what that is? Come on, guys. You've seen that, haven't you? This is the one architecture picture I could find, I mean architecture in the broadest sense, from Netflix. Does that look good? I don't know, it scares me. It really scares me, talking about ESBs and seeing that. But at the end of the day, it doesn't really matter what you name it or not. What we're doing today to be successful, at least partly, is that we decompose our really bad, old, monolithic applications into a new system and give it a new cut at the end of the day. I would like to call it componentization, which is not necessarily exactly microservices, but it enables microservices. So even if we're not doing like the full-blown whatever Netflix and co are preaching as of today, but we try to make a better software design for our applications and do something good. And I think the idea behind all of that is, with all the lessons that we learned, we want to reduce whatever impact changes actually have at that point. We really want to make sure that whenever we touch a part of our application, nothing else breaks. That looks pretty cool. Actually, whatever unreadable URL you find down the slides, make sure to download them afterwards whenever they are published. This is actually what I consider homework. So my daughter just went to school last year for the first time ever, and this is where I started giving homework at my talks. So whenever you find like a teensy unreadable URL, download my slides, check out whatever details I've been hiding down there, and learn a little bit about the particular topic. I'm not going to dive into here. But so far so good. How do we get there? Like from Java EE, what is the real important step that we're missing so far? It's actually a bunch of more homework for you. So I like to call those the 5 big principles of new componentized microservice-oriented architectures. So the most important part you need to look into is definitely the domain-driven design approach. It is out there since a couple of years. It's not exactly new, but it has a reasonable uptake over all those discussions around microservices and distributed architectures. I just have been asked by InfoQ about why I think that domain-driven design hasn't been an issue so far for many and why we kept ignoring it. And I have to admit, I think it's easy to just build something along the lines of the classical architecture approaches that we all learned. Domain-driven design requires a lot more business insights than we probably as software developers or architects or designers were used to accept. So this took a little while to get there. The other part is we need to learn to design for automation. So whatever application we're implementing is worth nothing if we're not able to automate everything around it. And that includes putting it to production, but it also includes a complete test cycle at that point. Okay, how do we get to services? This is basically the receipt that you have to find them if you're starting from greenfield, from nowhere, which is something that real enterprise Java applications never will have to experience. So we are mostly talking about trying to evolve an existing system without completely redesigning it. And you have a bunch of things that you could watch out for. So especially look for verbs or use cases that you find that might be good service candidates. Look for nouns in terms of domain entities that might be a good product, for example, like a product service. And the general rule behind all of that, try to cut services that have exactly one responsibility and nothing else. Sounds fancy, right? I mean, looking back at Java EE, how can we teach Java EE microservices? How does that really look like? I tried to make that picture from the first slide a little easier here. So we have our client, typical load balancing infrastructure, our deployed EF file, and a database. So the first thing, obviously, is slicing that into pieces and identifying the right parts to tear out of that application. And you might be actually able to package that individual new service or refactored service into a new web application archive and make it accessible externally. The only part that's missing in that case is some very little glue code in your existing application. It still needs to use that features that you just refactored out of your old application, right? So you need to have kind of a interesting part. Most importantly for me is the services as we learn to use them, especially the microservices today, all rely on a totally separated database. So you are not sharing anything between those two applications at the end of the day. Even the teensy little microservice needs to have its separate data model. And this actually leads to refactoring down to the database. So you're not coming away with just craving out something out of the old application. You really need to look at the whole stack at that point. Looks easy, makes sense. But does Java EE help us? This is like one of the most famous pictures that Java EE 7, when Java EE 7 has been launched, it's kind of the best of breed application specification, relevant stuff like JPA, WebSocket servlets. What is a service? What does a service look like in Java EE? Any ideas? Oh, we had just had lunch, right? That's the worst session of the day. Thanks, light is always a cool idea to get you guys up. Okay, let's make it simple. It's a very trivial thing at the end of the day, but it might look exactly like that. So it can be just a random stateless EJB component, which is exposed via JUXRS. I'm not really evangelizing JUXRS in particular, but I totally acknowledge that everybody, especially like the new reference architecture leads like Netflix or Amazon or whoever, they are kind of working with JUXRS over HTTP. So I'm not going into that discussion today. I still think it's a reasonable, good idea to get your hands and thoughts around like what a microservice could look like in Java EE. How could we deploy that at the end of the day? We already talked about like the deployment unit is going to be a WAR file. Why just a WAR file? Why do we skip using a full-blown EF file? Because we can, actually. We don't have to use an EF file anymore, at least not in E7 and onwards. So we could just simply deploy WAR files, and all the necessary specifications are almost all captured in the web profile specification. So you really don't have to use a lot more than that. And actually, if you're lucky enough to not use a full-blown application server at that point, but maybe you're able to craft your own implementation. So let's say Tomcat and put some more reference implementations next to it, or use something like Wildfly Swarm, which is kind of a best of breed, pick whatever features you need application server approach. You have a very lightweight service at the end of the day, and that could be it. So that might be what a Java EE microservice looks like. Seriously? Obviously not, right? So it's just 23 minutes in the talk, so we're not done yet, right? What's missing? First of all, obviously, the lightweight runtime. We don't want 30 minutes WebSphere starts. We want something that is lightning fast, blazing fast, at our fingertips, starts up in seconds. Is there anything that helps us with cross-service security issues in Java EE? Probably not. Transaction management, JUXRS? Nothing in there. Service scaling, like scaling services on a service instance base, probably hard with Java EE. Maybe vendor specific. If somebody comes up and joins the reign of latest buzzwords, they might come up with a Java EE microservice edition, which is pretty cool. Not. Load balancing. What else do we have? Deployment, like it's still the old funny binary thing that we throw over to operations, which probably doesn't work. Do we need any configuration? Probably we do, right? So is there anything in Java EE? Do we have a configuration JSR? We don't. Service discovery is actually the funny part, because especially if you try to recall the picture about the Netflix architecture, how could that work? That's not point-to-point, right? So there had to be some central component, to look up services, right? So nothing. Versions, monitoring, governance. That's a lot that we need to look into just from a microservice perspective. But what does a Java EE microservice really need? Like, what are the different options to deploy it? This has been like the first rough idea for many enterprises out there. We do have kind of container constructs already, right? We're running virtualization everywhere. We don't need fancy new stuff. But at the end of the day, you package a lot of stuff in your individual virtual machines that you literally don't need in first hand just for the business service requirements. So if we want to skip that, and we really want to skip that because we don't want to roll out like a 300 megabyte VM for every service that we deploy somewhere. But this is where actually Docker comes to the rescue. So this might be a very lightweight approach to actually scale and deploy services around everywhere based on images. It looks a little easier. We actually have some supported Docker images from community projects. So whenever you want to take a look at, for example, the latest Wildfly in a Docker image, just go to jboss.org/Docker and download everything here. But even if we are looking into Docker as a particular infrastructure component for microservices, this only solves like a handful of issues. We don't have to care about the lightweight runtime anymore that much because we have kind of a very isolated packaging format, an image that we could just use. It might solve something around scaling, at least if you are not only using Docker, but also something to orchestrate Docker. I'm not explicitly saying it has to be Kubernetes. Docker Swarm just recently got a lot better and also allows you to do a lot of stuff. Maybe it also solves issues around versioning a little bit, because you can version actually the images, but still not your application. But images are immutable, so it kind of solves it. It solves configuration issues, because you can actually use environment variables of the individual images to map them to specific container instances. So configuration is kind of solved, but you see, it's not like a checklist. It's not something that you could just cross off your to-do list at that point. Docker isn't solving everything. I think that's one of the biggest lessons at that point, because if we are trying to adopt the new architecture approach and all the new technologies in a very enterprisey setting, on top of a technology that's never been meant to be asynchronous and lightweight, that's always been meant as a centralized infrastructure, we really need to recall that doing stuff one step at a time is absolutely a solution to a problem. So my biggest takeaway at that point is, let's please try to do it in an evolutionary way. So don't overdo and over-engineer everything like back in the days when we started doing the older technologies. Here's a very simple setup, which could cover 99% of our requirements. So obviously we need like a simple service registry at the top. We need something to provide security to the services. We do need an API gateway to actually have a reasonable governance and versioning control. And we're still looking at the individual service, AA jar in that case, which is running on a Java EE instance. So, and to put some names and at least open source projects to it, to give you a rough idea what that could look like, I just put like FabricAid as a potential centralized service registry. It solves a lot more problems than just that, but it might be a good first step. There are a lot of load balancing infrastructures out there. Undertow is pretty much the newest kid on the block. It's part of the Wildfly family at that point, and it's a complete and integrated solution that has the potential to really use all the new technologies at that point, especially looking into Docker and Kubernetes. API Man can do both, like API gateway and downstream security. And I'm a big fan of running services on Java EE servers. Most importantly for me is just that those servers are really fast and lightweight, and that we have a chance to just customize it down to the needs that our little service really needs. If we don't use JMS or messaging in general, we don't need to have all those bloated dependencies there. And Wildfly actually, especially Wildfly Swarm, allows you to configure everything that is unneeded out of it. Here are some more slides about how load balancing in Undertow actually works. At the end of the day, it's a complete rewrite in Java from the Apache cluster module. So it looks pretty familiar. If you haven't seen it, it's the new web server in Wildfly 9.10, and give it a try. It's really, really impressive what those guys can do in terms of load balancing features. I brought you a very little screenshot from API Man at that point. The yellow bubbles should show you like the versions that you could assign to the individual services. And it also supports like kind of a workflow at that point. I'm not talking about Wildfly anymore. This is actually an example of FabricAid. More specifically, this screenshots have been taken from JBoss Fuse, which also incorporates FabricAid in that point. But FabricAid is in community version 2 already. So FabricAid is no longer just relying on what was there before. but also embraced like all the new technologies, Docker and Kubernetes at that point, and is definitely meant to be your number one middleware stop for all kinds of deployment, configuration, and scaling issues around Docker and more particular middleware images. So pretty much what we want to do is that we generate a bunch of service instances and Docker images and roll those out. What I haven't covered so far actually is the microservice pattern. This is not particularly my favorite part because I think it's still oversimplifying the situation at that point. But we basically have a bunch of ways to wire those individual microservices back together to an application. And it's not a big secret if I tell you that we've been doing like integration since a couple of years. So we do have like enterprise integration patterns that are totally feasible to use in microservice infrastructures. But abstracting everything around there away and trying to stick to the very basic patterns, you could end up with something like an aggregator. This looks familiar. Just imagine that the client in that point isn't really just a simple browser client, but maybe your mobile phone. So this is basically what mobile applications do. We do have a bunch of backend services in various qualities on various domains, and the mobile phone client actually pulls all the data together and displays like a cohesive user interface. You can chain services, for sure, if you really need like downstream information. In this case, like the service BN actually calls service FD, and so forth, down to service SA. Actually, this is a very critical pattern. I wouldn't actually downchain this too much because every service, depending on the technology you use in between, requires a particular service call, and you might end up with really long request cycles. So be really careful by chaining services like that. You can work around it if you have really good domain design underneath it, but you will have services that talk to each other. The branch pattern is obviously pretty easy, so you could actually have like a more centralized service that branches out to the individual downstream services, which could also be chained again. I think that's pretty straightforward. I highly encourage you to use asynchronous communication at that point. And JAX-RS 2.0 actually started to introduce exactly that. And there are also vendor-specific implementations that allow you to use JAX-RS in terms of asynchronous invocation. I'm not saying it's the best thing you could do, but Java EE is just not the ultimate microservice runtime in general. So it's kind of a trade-off you have to make at that point. Shared resources is a pattern that you won't probably find in the enterprise integration patterns, but I find it very valuable looking at enterprise projects because whoever had worked with separating existing databases and trying to migrate existing database schemes, this could be pretty impossible depending on how long the project actually is in place already. I doubt it's probably not doable at all. But if you still want to put like services on top, you might be allowed to have something like that, like a single database for 2 services. You run into all kinds of problems at that point, including transaction management, synchronous invocation. You need to really avoid that at almost any cost. If you can't, you have my permission to at least try it. But if you're really doing that, please don't use JAX-RS as a communication protocol over HTTP. It makes a lot more sense to actually use real asynchronous but transactional communication. This is another thing that I think is highly valuable, especially for enterprises. So if anybody tells you you can only do microservices with JAX-RS and HTTP, you're totally free to tell them, no, we totally can use message queues.
We totally can do that. This is probably an infrastructure component we already have in place. So why not just let's use that instead? And it's a reasonable alternative. At the end of the day, sounds easy, it looks easy, nothing very deep divey here, but there are a hell lot of challenges in here. And I'm not only oversimplifying, but also trying to encourage you to think about that by yourself, because takeaway number 2 today is, as of today, there is no silver bullet. There is no microservice infrastructure that you could just take, put your Java EE application into, and everything works just magically. You will get into all kinds of scary problems. Everything that has to do with distributed systems, with dependencies, with shared code. Remember when we started to first componentize our applications into various jar files and whatever? This is pretty much the state where we are in right now, but we really have to learn how to make that. And we need to remember that we learned how to manage those fragmented applications. And this is even more complex by now, because it's not only exactly one application anymore. The individual services could be running everywhere. If I'm thinking about like a 20-people team, and I'm thinking about 20, 30 services, I guess there will be a lot of challenges. Who's responsible for which service? How do the teams communicate at the end of the day? This is something normal, typical enterprises are not prepared for. There is something that you've also heard like lately as a buzzword, which is DevOps, that might help, but health checking, monitoring of the individual services is another big thing. Okay, we're still not done. Like, it's an endless list of warnings and head-ups and please keep in mind. We haven't even barely touched like the standard patterns that you find out there, like something, the circuit breaker. What do I do if a downstream service actually doesn't respond? Do I send an error to the client? Do I try to recover? Do I try to find a running version of the service somewhere? This is something that Java EE has nothing to offer. So you will be using something that is out there. I have some tips for you in a minute. Who's actually using DevOps as of today, like embracing DevOps and using it in the projects? Well, 1, 2, 3, 4, okay, fair. That's not a hell lot. I think this is a very, very relevant requirement around those new microservices infrastructures. It's just no longer shipping binaries from dev into test into production. It is a complete process, and we really need to be able to embrace the responsibilities that we get by implementing and distributing those services. So if you want to look into microservice architectures in general and make your Java EE services, Java EE applications ready for services, then you need to embrace DevOps as a culture, at least in your teams. And even more like question marks over question marks and things that haven't been solved so far, like as a standard pattern. We touched a few of them. Most problematic for enterprises, especially in Germany maybe, is that I am a big fan of having platform as a service offerings at hand for the individual microservices teams to really scale up and down their infrastructure as they need it. So, and if you're not using like at least a private cloud somewhere, you will probably run into something that is no longer working at that point. It is not broadly adopted by enterprises, even if many more actually look into platform as a service offerings like OpenShift. There's still a way to go for enterprises to catch up with that. Where are we? Lessons learned number 3 at that point, I think. The industry in large is still learning a lot. And if you are looking for individual solutions to problems, there are a bunch of frameworks out there that will help you, which probably don't fit into application servers and threading,
but you could definitely mix them. If you're not willing to roll your own solution, for example, a circuit breaker pattern or a service integration into your applications, then you might want to look into something like Hystrix. If you are thinking about how do I actually track like a user request, how do I track an error through, let's say, 20, 30 services downstream, which are distributed over different physical instances, you might think about something to aggregate your log files from the individual services. And that's where ELK comes in as a stack, like Logstash may be a good idea. And I've been talking about Kubernetes a lot, but there's another thing out there which is Mesos. Might also be interesting and helping you to solve issues. I'm not saying it's definitely the solution I'm presenting here. Correct functional decomposition of your existing application is probably the hardest part. You won't get it right from the very beginning. I can promise you that, because it's just grown over years, and you probably won't even find the business owners behind one or two of the original requirements. So give it some evolutionary approaches, give it some cycles to really come up with something that is reliable, and take teensy steps. If you have a modular system, you are pretty much on the right way. You don't have to really worry about the future, because it's the only way to jump off onto the microservices train in the long run. So don't hurry. And what you will have to do sooner or later is balance between the needs for microservices and the costs. I think it doesn't have to be like a 100% solution right from the start, because we can really create those new system architectures in many, many steps on the long run. Are they here to stay? Do we have to like deal with containers and microservices? I can promise you one thing. If you don't like containers and images and microservices, you will have a hard 5 years. This is what I think it will last at least before somebody else comes up with a new evolution in terms of technology. So yes, they are here to stay for at least a while, and we will learn a lot. Totally open pitch for my latest rumblings. This is actually not a 500 pages book, it's more like 85 pages. And it's even better, it's free to download, so you don't have to really buy it. Just go to the website mentioned down there, grab your share. It's a good summary of everything you heard today. It's something that you can pass on to your management and prep them for whatever buzzword bingo you have to play right now at the company. And I hope it helps you a little bit to position all the latest technologies in the context of the enterprise projects that we used to run as of today. Thank you. If you have questions, fire at will. Otherwise, I would let you out and me for a smoke. I'll be around, at least. Thanks a lot.